Hello. Hi, Lindsay. How's it going?
Going good, thank you.
Awesome. You're the first one in. Thanks for joining the call. Gonna wait for just a few moments before we get started. And everyone, I'm recording this. Hi, Gia. Welcome in. Let me know if you can hear me. Gonna wait a couple moments. Feel free to share your screen or not. I'm gonna record this and share everyone the video after, and then probably post it on YouTube if everyone's fine with that.
That's fine with me.
Thank you, thank you. Hi, Gio, welcome in. And I think there's not going to be too many of us today, so we're going to keep it semi-casual, go through. You can consider this kind of like office hours. And yeah, as we wait, can y'all like um you don't have to, you can briefly introduce yourself. You don't have to do a whole thing, but just like, just let me know what's like the hardest thing for you right now in chem and yeah, something you're hoping out of the session today.
I've been really sick for the whole week, so I haven't been able to attend lecture as much. And so I took the quiz in discussion, and I
Hmm.
think like, I did well in that. But I think like all the stuff that he covered, like the nomenclature and stuff, I'm not too good on.
Okay. Sorry you're sick. I heard a lot of people are sick. I heard there's like a cold going around, huh?
Yeah, like most of my friends have been sick.
Yeah, yeah, I heard a few people. Okay. Well, hope you're feeling better now. Hope you get well soon.
Thank you.
Yeah. What about you, Lindsay?
I think for me, I feel like I do pretty well in the quizzes, but when it came to the first midterm that we did, the first real exam, I
Yeah.
did pretty badly, and I feel like I just want to be able to iron out more details when I'm doing multi-step problems because I feel like I probably tend to make a lot of little mistakes when it's something that could be avoided.
Yeah, yeah. And I had you both of you have Dr. Hill, right?
Yes, I do. I don't know about her.
No, I do as well.
Yeah, yeah, yeah. I think most people do because that's there might be like a couple people from the other class, but I think mostly everyone has Dr. Hill, and hopefully you realize that he does a lot of math problems, right? It's like pure math calculations.
Yeah, he
Yeah.
does a lot of those.
Yeah, so it's like it's in a way it's not hard, but it is because all the math is like it's so much in a small amount of time, 20 questions, 50 minutes, right? Like that's a lot actually. That's a lot. So you don't really have to time to think. You have to like be really, sharp with it, right?
Yeah, and he doesn't like, I mean, like the homework problems that he gives, I don't think they reflect the midterm questions as well.
Interesting. Good to know. Because we have three we'll get started now. So we have three options today. I'll let you know what we have. Number one is we can do kind of lecture style, which I think is not gonna be the case here because there's only a few of us. So it's like, all right, Andrew, I'm lost. Start from the beginning. We can always do that closer to the final, where it's like lecture style. Second will be office hours, where it's like, yeah, I actually have a specific question, like I want to do number 37 or whatever. And then third option is kind of like a hybrid where we do some problems, and that's going to be my recommendation. Should we go like option three, hybrid? We'll do some like little bit of theory, a little bit of problems, and then I'll answer questions in between.
We can do that, yeah.
I
How's
feel
that
like that's
sound?
good.
Sound
Yeah,
good?
yeah.
All right. Perfect, perfect. So once again, yeah, I'm gonna start sharing my screen. And so, um, you said nomenclature. I think we can start there, yeah. And do you know what chapter? I have the book. I have the same book in addition. Do you know what chapter the nomenclature one is, by chance?
I don't think so, but I can try finding it. I'm not sure.
Yeah, because I know you guys had chapter 2, chapter 3, and then also like I guess that would be maybe 4. Okay. And then also practice problems will be for sure good. Oh, I guess it is 4. Okay, I didn't see that in the Discord. So interesting. Interesting, interesting. Cool. And then Lindsay, I forgot, did you mention a particular topic that you had in mind for today?
On the Google form, I put electronic configurations, but I think
Perfect.
mainly focusing on the diagrams that come with it, like the arrows and stuff.
Okay. And perfect. I think let's start there because that's chapter 3. So why don't we do a little bit of chapter 3 and then we'll do a little bit of chapter 4 and then we'll go from there. Because chapter 3 is going to be diagrams and electronic configuration. And I noticed he did it. Did he assign practice problems for electronic configuration?
I think he assigned a few.
A few. I didn't
I
see
have
those.
some. I have some problems. Oops. Hold on,
If
sorry.
take your time. If you can send me the problems, we can do those, or we can do like kind of like a quick review kind of thing too as well. Do you guys understand how like the 1s2, 2s2 stuff works? If not, we can start there. Should we start with a quick review?
Yeah, we
I
can
think
do
it would be beneficial, yes.
Yeah? All right.
Also, for that,
Mm-hmm.
can we go over the exceptions?
Yeah, good question. Okay, perfect. So I'm gonna go, and then again, since there's only a couple of you, let me know if I'm going too fast or too slow. Um, because sometimes everyone is at a different pace. So I don't want to start from the total beginning, but I do want to explain how it all works, right? Let's see if I can save this periodic table. And what I always say is for chemistry, periodic table is your bestie. Okay, that's going to be the most important thing, literally. So make sure you have one, and periodic table is your bestie. So what I'm gonna say is I'm not gonna say go to the periodic table. I'm gonna say, all right, who do we go to? Ask your bestie, and bestie is gonna be the periodic table. Sounds good? Okay.
Yes.
So we have here, so like if I ask you, let's just do a quick check. If I ask both of you to do the electronic configuration for, let's say, nitrogen, what would that be? Quick check. We have hydrogen here with helium, lithium, beryllium, boron, carbon, nitrogen. So what I encourage you to do is, um, is do them for all, like make a list of all of them. Hi, Elizabeth, welcome in. We're just getting started. Oh, wait, you guys cannot see my screen. I'm sorry. Let's let that load up. All right, can you all see my screen now?
Yes, we can.
Thank you so much. So, um, here's some optional homework that I really recommend. Go starting with hydrogen, number 1, helium, lithium, okay? And literally, we're gonna start with what? Hydrogen is what? 1s1, right? What is helium?
One is two.
Yeah, that's right. This is the S block. Okay. 1s2. And then the rule is we have hydrogen and helium. We can go over diagrams as well if you want the electrons too. We can talk about that right now. The rule is once you get to a noble gas, that's your like home base. So now we start here. So now for lithium, we have to copy the previous noble gas, which is helium, right? So that's going to be 1s2. And then now what's our new row that we're starting off here with lithium? Because that was the first row. And then the second row is now 2. Okay? And okay, maybe for context, maybe I should review the blocks as well. I skipped that. So first we have the first block. We're gonna have is the S block. This is going to be S, okay? And then what's the name of this block? So this is S, S. So the second column, except for hydrogen, and the first column, except for hydrogen, is going to be the P block, right? And then all of these, let's make sure we get all the ones on the periodic table. All of these on the right-hand side are going to be what? These are going to be our p orbitals. Okay, and then does anyone know the name of this entire section right over here?
The transition metals.
These are the
So
transition metals. Go ahead. Did you say the D block? Oh, excuse me.
yeah,
I'm wrong here. Apologies. This is the S. This is still the S block. Apologies. Okay, so all of this is S, S, P, D, right? And then I don't think, do you know if you're gonna have lanthanides and actinides? It's gonna be the F block. You might. I wouldn't be surprised if he goes all the way to F.
For one of
Okay.
the ones on the homework, I know, I think it included the F block.
Yeah. Okay. So yeah. Then we have lithium is 2s2, right? Beryllium, no, excuse me, 2s1. So beryllium, we have 1s2, 2s2. Okay. And you repeat that process. I encourage all of you to make a list of pretty much every single element and spend the rest of the afternoon going through and making those. Now, what is the shortcut? For instance, if we have after neon, let's say even after argon, and we have, let's say potassium, we want to get to potassium. What's the shortcut for potassium?
can you say like in like the brackets AR and
Very
then
good.
one and then 4S1?
Very good. Okay. So as you start to build those up for homework, you're going to see that we go to the previous one, which was AR, right? Argon. And then now we go to the next one, 4s1. Okay? Beautiful. And then what's that first rule for the transition elements? So for instance, what would be SC?
It would start with instead of 4, it would be 3D.
Good job. Okay. So there's some theory as to why, and we could always discuss theory. I'm a big theory proponent, but at the same time, like kind of don't worry about why. Just go argon 4s2. Oh, I gotta subtract one here. I'm gonna do 3D. I don't care why. Drew told me to memorize it. I'm gonna do 3D1. Okay. And so that's gonna go for all of them, I believe. Now we are gonna have some exceptions. We'll check those right now. And then same for like all of these blocks. Does that make sense? The rule is when we get to the D blocks, you have to subtract one from that particular element. Okay? Any questions so far?
No questions.
Cool, cool. So far, so good.
Yes.
Now, there's a lot to go over, and for the sake of time, we only have a couple hours, so I want you to again practice all. You have a bunch of examples in the textbook. Does everyone have the textbook?
I
I think,
haven't, but
yeah.
everybody else.
I think someone sent me the PDF, so if you need it, just let me know. I'll send it to you. Okay. And there's tons of exceptions, lots of different cases. One really, really common one is going to be iron. And in particular, I'm just taking a random look here at condensed this is example 3.12 for Fe2 plus. And then does everyone understand like charges and on ions and cations? Kind of. So if I this is really important. This is going to come back in general chemistry, and anyone that's got to take OChem, this is going to haunt you for the rest of time. If something is gaining electrons, is it going to have a negative charge or a positive charge? Something is gaining electrons.
A negative charge?
Very good. So if something has a positive charge, does that mean that it lost electrons or gained electrons?
Lost electrons.
Very good. So does that mean that Fe2 plus lost 2 electrons or gained 2 electrons?
Lost two?
Very good. Does everyone understand that? So it's like a double negative. Okay? Because electrons are minus. So if they lost 2, it's going to have a positive charge. If they gain 2, it's going to have a negative charge. So I'm at Fe2 plus, and now I'm isoelectronic to what? And by isoelectronic, I mean which element is iron pretending to be?
Chromium?
Right. So I'm kind of looking at this guy here, and this is going to be 3D6. Okay. So if I have regular iron, let's do regular iron. We have, whoops. Let's do regular iron just to make sure we're all on the same page here. I'm gonna have what? I'm gonna start with argon, right? Because that was the previous element. That was the previous noble gas. And then what's my next section here? This one is 1, 2, 3, 4. Again, let me know if I'm going too fast or too slow. If you're like, hey, I have no idea what you're saying, just let me know. We're gonna have 4s2, and then remember the rule is I'm gonna shift that over. So what do I gotta put here for just regular iron? I'll give you a hint. It's something after, I guess I kind of wrote it already. If you saw that, yeah, that's what it was. So what was the rule for the transition elements?
It's gonna be one less
Very
than
good.
was.
Which is one less, that's a 3. And what's the block?
D?
The block is D. And now for regular iron, I'm gonna count how many do I have to get to iron.
Six.
Very good. We have 1, 2, 3, 4, 5, 6. All right. So for regular iron, we have 1, 2, 3, 4, 5, 6. Okay, 3d6, 4s2. And then we're gonna try. Any questions about regular iron?
No questions.
So far, so good. So now I want you to do Fe2 plus and Fe3 plus, and my only hint for you, if you haven't done this already, is gonna be remember that guy and that guy. We have to do the rule. And again, if you don't want to discuss the theory as to why, I'm more than happy to do so. So one of you go ahead and give me Fe2 plus if you can, and then one of you go ahead and give me Fe3 plus if you can. And I'll start it off. Argon. Okay.
For the 2 plus, would you be taking from the 4s one?
Yes, you would, because that's the lowest. That's the one that's kind of like easier to grab. Okay. So very good. So if I essentially eliminate that one, that kind of just goes away. Okay. So I'm gonna have 3d6 and it goes away. So does everyone understand why I did that?
Hey, can you go over that?
Yes, of course. Think of it as like we're gonna do these diagrams real quick. Okay. And I want to think of it as like I want to grab the easiest, I want to grab the low-hanging fruit. So if I'm in a tree, okay, and I'm gonna grab these two versus these two. Okay, this is option A and option B. And you want to grab the easiest fruit. Obviously, which one's easier to grab, A or B?
A.
Okay, very good. So A is going to correspond because it's lower on the tree. A is going to correspond to 4s2. And so um and so Drew told you that 4s2, or maybe Dr. Hill told you that 4s2 is actually lower than 3d6, which is a little counterintuitive, and it's like a kind of like a memorized thing, but it's in your textbook. Okay? It's like just memorize that. Normally, yes, the number 3 is lower than 4, but this is like one of our first exceptions. Okay? And this is only for transition metals, by the way. Doesn't happen for everything. So that's why we're going to grab our two 4s ones first. Okay? Did that make sense?
Yes, thank you.
Cool. And then for Fe3 plus, now we're going to take away one more electron. So what would that electronic configuration be for 3D?
Would it just be 3d5?
Very good. Perfect. Perfect. So hopefully everyone's getting the hang of it. Any questions so far?
No questions.
Yeah, um so Lindsay said like, "Oh, like I get it." And then during the quiz, like I do all right, and then during the exam. So like, yeah, easy enough, right? But on the exam, we took what, 5, 10 minutes to explain that. On the exam, you're gonna have four of these to do per question, and each question you have about 2 to 3 or even 4 minutes max. So meaning you have to do these in about a minute tops each. Okay? So those are some exam strategies, meaning that later today, you know how we took our time to like conceptualize the tree and going to AR 3D6 and like taking our time with it? That's fine while you're studying, but the goal that I want you all to have, okay, everyone, is get to the point where you can kind of like be really quick with it, do it in your sleep kind of thing. Does that make sense? Yeah, that's gonna make or break your grade for Gen Chem because it's like, okay, it's good enough, I get it, but each of those multiple choice sections is gonna ask you. And I wish we had, yeah, I wish we had like a practice exam or something, but it's probably gonna be like which of these is right or which of these is wrong. Like I can see a hard one is like which of these is incorrect. And so you're gonna have all of these different electronic configurations, you know, like it's gonna say, like it's gonna label it, for instance. Let's just do one real quick. Which of these is incorrect? This will be an easy version of the harder version. So we're gonna just do Fe AR 3D6 4s2 Fe2 plus AR 3D5 4s2 Fe2 plus AR 3D6 Fe3 plus AR 3D5. And they could all be different. You see what I mean? So that I wouldn't be surprised if he give you something like this. And so what's everyone thinking for this one? A, B, C, or D?
B.
I'm sorry, one more time. What did you say?
B.
Yeah, did you say B? I got basically I just made up this one, right? I just kind of made up a random one. So we just discussed that was our first one. 3D6. Oh, I'm sorry. I meant to erase that. Apologies. So I just made up this problem right now. So that was our original one, and then that was our Fe2 plus, and that one is correct, and that one's correct. So this one is not correct because I just made up that one on the spot. Okay? So I encourage everyone to try that like as many times by doing the tons of examples and practice problems. Okay? And cool. That being said, yeah, do we want to take a look at some more examples like practice problems or like a different topic?
Would you be able to show really quickly how to draw the I don't know what they're called, the diagrams, the one with the boxes and the arrows.
Oh, okay, okay, that's gonna be our electronic. Yeah, perfect. So that was right before this actually. So now that we have our arrows, I want everyone to go to, I wonder if he's gonna provide this. Like I'm in the book. I'm in chapter 3 here. I hope there is a, yes, this is what I was looking for. There should be something like this, and I'm wondering if he'll provide it, maybe or maybe not. I encourage you to just practice it, anyway. Um, this is gonna be your, how to call it. I can't think of an analogy right now, but it's just gonna be your order here. 1S, 2S, 2P, 3S, 3P. I just realized the tree analogy is actually the opposite case because it's going from top to bottom. So the tree analogy, I don't want you to get confused. When I said the tree analogy, you're grabbing the low-hanging fruit. Actually, whatever's on top is the easiest to grab. Can someone please explain why is the top electrons easier to grab than the lower electrons?
Because they're like the valence electrons.
Mm-hmm. Mm-hmm. That's right. That's right. You can think of down here, this is close to what? This is very, very close to what in the atom? Is it very close to a positive charge or a negative charge? Aha. This is testing a little bit of theory. But he tends not to ask about a lot about theory. Okay, down here I'm very close to the nucleus, right? Because think of these are shells. Okay? So down here I'm close to the nucleus. So these are electrons, right? And are electrons negative or positive?
Negative,
Good. And then is the nucleus negative or positive?
positive,
Right. So down here, are these electrons very, very glued or very, very easy to escape? Very attracted or very easy to escape?
attracted,
Very, they're tightly bonded to the nucleus, okay? However, these ones are at the top and they're kind of like pulling out some weeds. They're far away. They don't have any attraction to the nucleus, so they're gonna get released. Okay, so hopefully you understand that because me explaining that, that's the theory, that is actually has exactly to do with how to draw these. So these arrows represent our electrons. And let's discuss all the rules. I think that's what we can do. Hopefully there's like a box here where it shows all the rules. Yeah, yeah. So we have Hund's rule. So let's do a couple examples. So let's say I want to do carbon, and let me share my screen one more time. All right, and then okay, so I have carbon here, and then I'm gonna pull out my periodic table. And number one, first things first, I want to do the electronic configuration and I want to do the orbital diagrams. That's what you're asking about, right? Lindsay, you're asking about these diagrams?
Um, yes, like the one that has like the boxes with like the half arrows and the down half arrow.
That's right. Perfect.
Okay, perfect. Thank you.
Yeah. So to do this, step one, I need to do the electronic configuration. So what is the electronic configuration for carbon based on my previous knowledge? So I'm going to start off with section one. I'm going to be 1s and perfect. So I have 1s and then what's next? So I have
2s2.
uh-huh. 1s2, 2s2. Okay. And then 2p what for carbon?
2.
2p2. Because I'm over here. So 1s2, 2s2, 2p2. Okay. So all right. Let me know if there's any questions about that. Do you see how I'm doing that? It's kind of like memorizing everyone, but it's not like memorizing, it's just like you kind of get used to it. So in a moment we'll do carbon, and then in a moment let's do nitrogen as well. Just so everyone gets this down. Maybe I'll help you get started on your guys' optional homework, which I said to get that. Okay. And so they're all gonna have all three of these. Duplicate, duplicate, duplicate. Okay. So we have 1s2, 2s2, 2p2. Let's start with carbon. This one, first box is going to represent the 1s block. This box is going to represent the 2s block. And then these three blocks are going to represent the 3p block. Let's do one more. We're going to get to neon. And then we're going to see why neon is... We're going to get to why neon is a noble gas. And a quick little side note. Chapter 3 is basically like Dr. Hill focuses on practice problems, but this entire chapter is a theory chapter. The way at UCR does it, who took chemistry in high school?
I took,
did.
yeah, I did too.
Mostly everyone. So maybe in high school you thought like, chemistry was like stoichiometry and balancing, and yes, it is. There is a lot of that. But at UCR in college now, you're starting, I don't know if you realize, but they're starting from the ground up. So they're explaining everything from the theory, from like literally what is an atom, literally what is an electron, and building it all the way up, 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 up. Okay? So A is basically like if you master A, then when you get to B and C, you're going to be like, oh, I know this because in A they explained this and that and that. I struggled with C because I was bad at B. So when I got to C, I was like, "Oh, Chem C is so hard," but that's because I sucked at Gen Chem B. Okay? So I want you to really really work hard to understand this chapter because this is going to explain the rest of general chemistry and organic chemistry too. Who has to take OChem? Bio majors?
I don't have to.
You don't have to? Lucky you. Or not. Anyone else has to take it? What's everyone's majors, by the way? I meant to ask that in the beginning.
I'm bioengineering.
Bioengineering. Perfect. Beautiful.
Math for teaching.
Math major. Awesome. Cool, everyone. So a little side note though, because if you understand that the fact that this is theory, like it's like it's gonna be important for later on too. Okay, and then 1s2, 2s2, 2p2 means that we have our 1s block is going to be filled. So the way we do this is going to be each arrow is one electron. So I'm going to go an up arrow, just like that. Up arrow, that's my first electron in the 1s block. And then a down arrow, that's my second electron in the 1s block. And now I'm done. So I'm going to put a check mark in my mind for here. Now I'm going to move on to this one here. I'm going to go a little bit faster because it's already 11:36. I'm going to put an up arrow for my 2s1. That's 2s1 and then 2s2. So now I'm going to check this one off. All right. Now I'm over here and I got to be careful because I can't fill each one up until I go to the next one. So I'm going to go 2p2. Okay, so here's a potential trap. Do I do this? Bum, bum. Is that right or wrong?
Don't you have to do the ones facing up first?
Very good. So I have to go one and then skip Why? We don't care because this is quantum, and that's upper div stuff. We don't care about it, okay? Just memorize the rule. This is called Hund's rule. And we say, hey, Hund's rule says I have to go up first. Okay? Hund's rule. Does that make sense? Okay. So now let's try it again for nitrogen. So I'm gonna have 1s2, 2s2, 2p what?
3.
2p3. Very good. So notice that I had everything I had before, which means that this didn't change, and this didn't change, which means that this isn't going to change, and that's going to be the same. So I'm going to just quickly go up, down, up, down. But now I have 1, 2, 3. And so according to Hund's rule, I'm going to go 1, 2, 3. Just like that. Okay? So far, so good?
Yes.
And then now my next one is oxygen. So now I have 1s2, 2s2, 2p what?
4.
Just 4. I like how everyone's saying 4 question mark, 3 question mark. It's 4. Yes, it is. 1, 2, 3, 4. All right. Now, according to Hund's rule, I got to do what and then what? So I have my 3 plus another 1, so I'm going to fill that one here. 1, 2, 3, 4. Does everyone see how I did that?
Yes.
Yep. Thank you. Thank you. Now let's do a couple more. So again, same question for y'all. So someone please do fluorine, and someone please do neon, and let me know what you get. Do I have anyone that wants to try it out?
For fluorine, it's 1s2, 2s2, 2p5.
Mm-hmm. Good. Good job. So I'm gonna do that, up, down, up, down. And then how many electrons on this side?
5.
Very good. 1, 2, 3, 4, 5. Okay. So once again, does everyone see how I did Hund's rule here? I didn't do 1, 2 first. 1, 2, 3, 4, 5. This is a coincidence because I got the same answer on accident, but I don't want you to do it this way, okay? I want you to go, right? 1, 2, 3, 4, 5. Okay? And then last one. Someone want to do neon? No?
For neon, it's
Go ahead.
1s2, 2s2, 2p6. So all of them will be filled up.
Perfect. And so therefore, because of the fact that you said all of them filled up makes neon what type of element? It has a complete octet. I think technically that's a different chapter. Okay, but this is filled. In this chapter, we're gonna just say filled electrons. In the next chapter, if you recall from high school chem, we have a complete octet. That's gonna be a later chapter. Probably
That's when the outer shell is filled up all the way, right?
That's right.
Okay.
So as you can see, right, guess what? All of these are filled up all the way. Okay. So again, once you get to, let's see what chapter that would be. I wonder if that's gonna be A or B for you guys. That's gonna be chapter 5. That's gonna be on the next exam. Okay. So if you understand chapter 3, it's gonna help you understand chapter 5. Okay, and 4 as well. Yeah. Maybe you've seen that in chapter 4. All right. So yeah, any questions?
No questions. This helps me visualize it better though.
Helps you visualize it? Perfect. So again, I can't emphasize this enough. If you understand, like, how do I say this nicely, but also like tell you the truth? So I'll just be blunt. If you understand this, good job. I'm proud of you. But this is not enough for the exam. I want this to be ingrained in your head so that no matter which element I give you, it's not, oh, 7 question mark, it's 7 or 5 question mark. Like you know what I mean? Like you like right away because you have limited time. Okay? This is not fear mongering. This is not like trying to scare you out. It's just like, all right, we gotta be quick with that. So that's where the practice problems come into play. And beautiful. That being said, again, do we want to do like some more examples, maybe some harder ones for these?
Can we do ones that have the F block in it?
Yeah. Yeah, great. So as a matter of fact, I think why don't we jump to okay, I think there's one example here, or we can jump to the practice problems. Did he
Um,
assign yeah, electronic configuration problems?
on 3.90, it uses lead and it considers the F block.
Okay, perfect. Let's do 3.90. Beautiful.
I
This
tried
is
doing it on my own, but it got really messy, so I really don't know. I want to be able
see
to go over it again.
see this is good. This is where we want to be and do these harder ones because right now this is like intro stuff and again like I'm happy to explain it step by step but we gotta like you know so it's kind of long here. Is this multiple choice? Yeah, this is kind of a challenge one. So 3.90, right? Okay. And it says which of them perfect, it says which of them are PB2 plus and PB4 plus. All right. So let's just kind of like write it out and let's kind of go one at a time. Step one, we got to get the electronic configuration for each of these. So let's go with PB first. And sometimes the hardest part is just locating it on the periodic table. So where is that going to live? I see it right over here, right? Okay. So now we're passing what? We're passing both of the lanthanides. So yeah, now we have the F block. And that's all full, right? So what's my shortcut here?
Will we use xenon?
We're gonna use xenon in brackets, good. Xe. And right after Xe, we're actually, let's see if they gave us a hint in the problem. They kind of did. We can automatically eliminate A and B because none of those have the F block, right? Does everyone see the problem?
I have it pulled up, but I don't know if the other person has it.
Let me pull it up because then you guys can have that in the recording too. Okay. So again, it says which of the following orbital diagrams best describe the ground state electrons? And we said, hey, notice how PB goes through the F block, and A and B do not contain the F block, so let's not even worry about that. And so now we have a couple hints because we see, notice how all of these have the 4F block first. Okay, and notice how they're all filled. So for all three of these, we're gonna have 4F12. 1, 2, 3, 4, 5, 6, 7, 14 rather. 4F7 times 2 equals 14. Okay, so I'm gonna say for lead, I'm gonna say XE 4D 14. 4F 14. Okay, so does everyone understand how I got the 14? 4F 14? That's the lanthanides, the F block, and the actinides, which live down over here, and that's our F block. Okay?
But when moving from, sorry, question. When moving from xenon to like the next part, why aren't we considering the 2s, or it's not 2, 1,
It'd
2,
be, I was thinking the same thing. So I was like, hey, why didn't they do 1, 2, 3, 4, 5, 6?
6s2?
6s2. So that's what I would have done. But kind of like how before our D ones come before our S ones, it's kind of the same logic here. And you don't have to know that right away. I use this as a clue. I didn't know that. I was gonna say what you said. I was gonna say 6s2.
Mm-hmm.
But then this was my clue that that's gonna be first. Great question, by the way, because I was thinking the same thing.
So would
Great
it still
question.
work if we did it the way that we were doing it before and just reorganize it afterwards?
Let's try that out. That might still work. Just for the sake of clarity, why don't we just try out, hey, we know that we're in, what did we say? I'm sorry, Lindsay. We said 6, right?
6s2.
2, 3, 4, 5, 6, right? So we're gonna say something something 6s2. Because I don't care about the order because I hate memorizing, but as long as I understand, right? Then that's gonna still work. And then where does lead where does lead live? We have to go all the way across what? Which block is next?
The F block?
We we have that. Okay, perfect. Yeah. So we canceled out the S block and then we canceled out the F block. So now we have 6s2 and we're gonna have 4. So just like how in the D block we subtract 1, when we get to the F block we subtract 2. 4F14 and the 14 comes from 7. 7 times 2. Okay? So far so good? Kind of. Then now which block are we in?
Is it the D block now?
Very good. Remember, we're trying to get to here. So how many in the D block are we gonna have? And which order are we in the D block? If this is 1, 2, 3, 4, 5, 6, which
Is it
number am I gonna
5?
put first? Very good. 5, D. And then if I want to go all the way across, sorry, my iPad's acting up. If I want to go all the way across, I gotta go to 5D what?
10?
Yeah, yeah, because there's gonna be all these elements here. And even though the lanthanide is not shown here, we still include it. So now we're all the way across here, so I eliminate all of these. Okay, now I have a couple left, which is gonna be what?
We're in the P block now?
6. Good job. 6 P and that should be 1, 2. Okay. Does that make sense, kind of? I went to P block, 1, 2. Okay. So now, that being said, let me pause here. Because as long as you write down the electronic configuration, which is kind of the hardest part, now we're gonna see which one of these is correct. So let me pause here. Does everyone understand this part? This is the hard part.
Yes.
Kind of, yeah. Okay. So now I have this electronic configuration. And now I gotta see, now that I have this, it makes it a little bit easier to visualize. Look, all of these are the same, so I don't gotta worry about that. My D block is filled, so I can eliminate which one for PB.
We
It's
can
not going to be F.
Very good, right? Eliminate F. What else can I eliminate?
G?
G, right? Because my F block is filled, filled, filled. Notice how I have an empty gap here and an empty gap here. So I have to eliminate those. All right. And then which one is just straight up wrong that I can also eliminate that you would never see?
E? Because there's nothing in the block.
Cool. E, because there's nothing in that last block. And then I was going to suggest you never see this. This is a trap. Never, never have this. Never say never in chemistry. There's always exceptions. So let's be careful there. But in my head, I eliminated that one. So therefore, for lead, the correct answer is D. We're going to erase all of that, except for A and B, which is going to be irrelevant because it doesn't have any F blocks. So we're going to label this one as lead. Okay. Questions? I
No
promise.
questions.
I promise if you rewatch the whole thing from scratch and like do it by yourself and pause and play, it's gonna be crystal clear as day. And teach someone else. Okay? I'm learning a lot by doing this. Okay? By the way, I'm learning a lot. Okay, when you teach someone else, that's the best way to learn. Cool. Now we finished lead. Now we're gonna do lead 2 plus. So lead 2 plus looks quite like that. And Lindsay, to answer your question, for lead, right now we were safe because even though we got the wrong order, we still got the right answer. Hopefully. Okay. But now we might not get so lucky. So we gotta be careful. If we're subtracting, now I have PB2 plus. So the same question. If I have PB2 plus, am I adding electrons or taking away electrons?
Taking away.
Taking away, right? So if this one was my highest one, by the, let's call it the law of the low hanging fruit, which one am I going to take away first? Remember when I asked you earlier, is something glued to if something that is glued to the nucleus versus something that is far away from the nucleus?
Would you just take them from the 6p
Very
block?
good. Okay. Eliminate those, which means that corresponds to which one?
E.
That's it. So now this one is PB2 plus. You see what I mean by like this is the hard part? And now that we have the hard part out of the way, it makes this scary looking Hund thingy not so scary anymore, right? Last one, what about PB4 plus? So now we took away these two. What are the next two I got to take away?
You're taking from the S block for the next one?
Mm-hmm. Just eliminate these ones. Which corresponds to which one?
G?
G, right? PB4 plus. So I'm just picking off 2 electrons at a time. First, I eliminated these two. Then I eliminated these two. Now I'm left with that one is empty, and the rest of those are filled. Does that make sense, kind of?
Yes.
Cool. Cool, cool, cool. So beautiful. That was kind of like a crash course of chapter 3, and then you still have a lot of other stuff, chapter 2, chapter 3, like I know chapter 3 also has a lot of like light stuff too. Some people ask about that. I'm thinking for the sake of, is chapter 4 going to be on it? Have you already, because someone said ions. Should we jump to chapter 4 now? Because we did 1 hour, chapter 3, now move on to chapter 4. Does that sound good?
Yes.
Cool, cool, cool. Thank you, thank you. Um, Let me just take a quick look because I haven't reviewed this one yet. Okay, this is gonna be compounds. So now that this is what I meant by what I said earlier. Now that we understand chapter 3, now we're gonna use that to build the atoms from the ground up. They literally do it very fundamentally. Now we're gonna build the atoms from the ground up. When when did he start chapter 4? Did he already complete chapter 4, or is he still finishing this one up?
I think I know he's on what day is today? On the last lecture that we had, he was working on stuff from chapter 4.
Mm-hmm. Okay, okay. So that was that yesterday?
Thursday.
Thursday? Okay, so he's probably like on it, finishing up. He's right around chapter 4. So if he's not done with that, I'm assuming he's probably gonna done with it very soon. But
We left off on being able to name like the compounds, I think they're called.
uh-huh,
Like
uh-huh,
Fe2O3, calling it iron 3
uh-huh.
oxide or ferric oxide.
Fair warning, he loves naming because he's an organic chemist. So he loves naming. So I think we better go over that. Let's go over naming, okay? And he probably is gonna love Lewis structures as well. By the way, again, whoever got to take OChem, chapter 4 is pre-OChem. So chapter 3 is pre-chapter 4. Chapter 4 is pre-OChem. I cannot emphasize, because I teach OChem too. I teach OChem as well. I cannot emphasize enough. The people that struggle with OChem, it's because they forgot their chapter 4 stuff here. So whoever got to take OChem, this is the stuff. Did he do Lewis structures yet? Did he do like bonding, like like the molecules, like building the molecules, Lewis structures?
I don't. I think I might have been mentioned, but I did take bio last quarter, so I could have been confusing it between that too. So I'm not sure.
Okay.
I don't think he started that yet.
Okay. No worries. Hi, Eduardo. We're going through here. We're about to do chemical bonds and stuff. Welcome in. And perfect. So let's do naming. And I want to show everyone if there's like a thing in, okay, first things first. I just want to talk about this because this is probably like one of the most important things in general chemistry is this is like one of the most important things ever. This is this graph. Does anyone understand what this graph represents? Let's start here because this is going to explain this entire chapter. Maybe not.
I don't
Maybe
really know what I'm looking at.
Okay, let's start here. All right, let's start here. Perfect. So that weird table is gonna be crystal clear as day right now. And like this is like one of the most important things ever. So remember how we said that neon, okay, this is basically, let me just double check because I asked you if we have the octet rule and whether it's here or not, I'm gonna teach it to everyone. Whether it's here or not, it seems like I'm gonna teach you something that you're gonna learn next week, but trust me, it's gonna make everything click, okay? So I'm gonna teach you something which is called the octet rule. It's gonna make everything click. We received a request to record to the cloud. Uh, what was that? I'm gonna just cancel that. So, okay. Here's what I want everyone to do. And fortunately, I already have a video up on this one. Perfect. So you guys can watch that one after I'm gonna send that to everyone. So I want everyone to take your periodic. Does everyone have like, what does everyone have? iPad, pen and paper. Do you have a printed periodic table?
I use my iPad.
Okay. I want everyone to get out your periodic table like I have it here. If you don't have it on you, it's fine. And um we're gonna mark it up. So column 1, we're gonna put a 1. Column 2, we're gonna put a 2. The transition elements, remember we said last time, these are exceptions, so we don't worry about it. Chapter 3 is the only time you're gonna see this block. Once you're done with chapter 3, no more chapter 3. You're not gonna see it in OChem, you're not gonna see it ever again in your entire life. But you are gonna see this block, especially who's a bio major, who's like biochemistry, bioengineering.
I'm bioengineering.
Bioengineering, yeah. So this is your block. Carbon, nitrogen, oxygen, sulfur, phosphorus, hydrogen. I want you to, like, how do I say this? Master those elements. You know? Then you're gonna go to the right-hand side and we're gonna build the octet rule. And then we're gonna put an 8 over here. Okay, we're gonna put an 8 for 8 valence electrons. And we're gonna put a 7 in red here. Let's use black here for the thing, the column. 8 on the right, 8, 7, 6, 5, 4, then 3. And then you're gonna take whatever number that's there minus 8. Okay, and that's gonna be the charge. So what is 8 minus 8?
0.
So we're gonna put a plus 0. So what is 7 minus 8? So everything that is in this column is the noble gases, and that is always plus 0. Always, 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 always. Because they're noble gases. Now, what is fluorine, chlorine, bromine? What is 7 minus 8?
1.
Minus 1, right? So all of these are gonna have minus 1. Okay? Let's continue the pattern. What is 6 minus 8?
-2.
Minus 2. And then notice I'm gonna stop over here. You are gonna have fluorine, chlorine, bromine, iodine. You're not gonna worry about tellurium, selenium, so I put the box right here. Continue the pattern. So what is 5 minus 8? Minus 3. So I'm gonna box this so these ones have minus 3. Okay? Now for carbon and boron, now it's getting kind of far, so you're not gonna really see minus 4 plus 4, so we're gonna leave those. Okay? So the black here is the number of valence electrons. And then the blue here is called the formal charge. And okay, can't box that. And perfect. Is that making sense?
Yes.
And then due to water for chemical engineering, yes, but also you already know for chemical engineering it's gonna be more physics than anything, right? And then so yeah, you're gonna see this too for Kenny.
Yeah, yeah. I'm noticing.
You're doing good, man. You're doing good. By the way,
I'm loving it though, so that's fine.
good job, good job. Yeah, yeah. All right. So now we have 0, -1, -2, -3. And so now, okay. Now everything on the right-hand side is +0, and all of these elements are happy. This is called the octet rule. I'm trying to think of the perfect analogy. This one may or may not work, but I think it's good enough. So the ones on the right-hand side, they are rich. You can do cookies, you can do money. I like to do um people, okay? So the one that someone said was on the right-hand side we have Kendrick, or we have, you know, Kim Kardashian, because they're done. They're done, right? And then one to the left, they're neighbors. Okay, so they're pretty rich, but they're not as rich as Kendrick or Kim Kardashian. So over here we have Drake, right? So Drake is pretty rich because he has 7 valence electrons, and that's fluorine, chlorine, bromine, iodine. But he hates Kendrick because he's like, damn, I can never be Kendrick. Like, damn, if only I could have one more valence electron, I could be just like Kendrick. So what's Drake gonna do? Meanwhile, poor hydrogen. Hydrogen is we're gonna be nice, so hydrogen is just gonna have, and I promise after next lecture it's gonna make way more sense. We're gonna just say hydrogen is just one electron. So hydrogen is like, now for the sake of like being nice, I don't want to like call anyone out. But hydrogen is like a kid that has like one cookie, and he's like, you know what? I have one cookie. I feel bad for fluorine. I'm gonna give it to fluorine. So fluorine has 7. 1, 2, 3, 4, 5, 6, 7. So fluorine is really, really greedy because fluorine is Drake, and Drake is gonna steal this cookie and he's gonna pretend to be Kendrick. He's gonna turn into F minus, F with a full octet. So now Drake is happy because now he has a full octet, but he has a minus charge. The minus charge means that he's getting punished for stealing. Okay? The reason he has a minus charge is because he stole the cookie. Think of it like that. So, fluorine is the most electronegative element on the periodic table because he lives next door. He's a next door neighbor to Kendrick. Kendrick is all happy, lovey dandy. And Drake is desperate for clout because he knows he can never be Kendrick. Does that make sense? Or did I lose people? Like, this makes no sense.
So basically, they want to be like the ones with the most, like they want to be able to fill their shells
They
like as
want to
much as they
fill the
can.
shells. Exactly. They want to fill the shells. Okay? So chlorine similarly, so all of these, they're desperate, but fluorine is extra desperate, and we'll talk about why. But I just want you to know that fluorine is extra, extra desperate. As we go down, they're not as thirsty. They're still clout chasing, but they're not as desperate. Okay, we'll talk about why. And I encourage you to think about why. I encourage you to use your chapter 3 logic and consider why is iodine not as desperate compared to fluorine. Similarly with oxygen. Oxygen, think about why. What's the difference between the electronic properties and the nuclear properties? Why oxygen is not as desperate as fluorine. So as we go to the left, they're less and less braggy. And as we go down and down, they don't care. So the trend is as we go up and to the right, fluorine except for these ones, because this is the bridge. Fluorine is the hungriest for clout, and he's really, really, really desperate for clout chasing. He's gonna do anything. He's gonna be on Degrassi. He's gonna like try to like, he's just clout chasing constantly because he can never be Kendrick. So fluorine is the most electronegative, and down here we have the least electronegative. So the trend is up and to the right. That's the key takeaway from this silly little lecture. It's up and to the right. Okay? Did that make sense?
Wait, I have a question.
Yeah, of course.
Is it okay? I don't know if I'm relating this to the right thing because when he talked about in lecture, is it electron affinity that we're looking at?
Yes.
Okay.
Electron affinity means how this electron affinity is a synonym for the word electronegativity. So he calls it electron affinity. I'm going to call it electronegativity. Same thing. That's what we're talking about here. Okay. So now when I pull up that diagram one more time, hopefully, pop quiz before I pull it up, what was the trend for the diagram? Was it up left, down left, bottom right? What was the trend?
When you go closer to the upper right,
Upper
you're gonna
right.
be more hungry for the electrons.
Perfect. Good job. And what do we notice about this funky table that 10 minutes ago you said you have no idea what I'm looking at?
They're getting taller as they go more closer to fluorine.
You're getting taller as they're going closer to fluorine up and to the right. Is that making
I
sense?
have a question.
Mm-hmm.
Would this just be the same as them like trying to reach stability?
Yes, that's exactly it.
Okay.
Okay, so they're trying to become more and more stable. They're trying to complete their octet. Now, cool. Does that make sense? Because if that makes sense, that's the first step for this chapter, and then the rest of the chapter falls suit from there. I want to just take a quick pause. So quick pop quiz. Which one is more electronegative? Chlorine or sodium?
Chlorine?
Chlorine is more electronegative because it lives on the right-hand side. Which one is more electronegative? Oxygen versus carbon.
Oxygen?
Oxygen is more electronegative because it lives on the right-hand side. Which is more electronegative? Aha, bromine or iodine?
Bromine?
Bromine is more electronegative because it lives upper. Okay, so there's two parameters. There's the right-hand side, which has to do with atomic size, and vertical, which has to do with electronic structure. And he's going to talk about why, or if he didn't, come back to me, and that's important.
I have a question. Sorry.
Please.
So would nitrogen be more electronegative than bromine?
Now, that's a really good question, and according to the data, yes. According to the data, yes, because we see 3. That's its electronegativity compared to bromine 2.8. But sometimes, as you've seen, chemists can be really mean because they're like, oh, how can I trick these people? Thankfully for those, that's a really, really close call. I don't think they would ever ask you that close because those are competing parameters. Nitrogen is smaller, but nitrogen is smaller, but it has less of electronegativity. Whereas bromine is more electronegativity, but it has more protons, so it's going to have some canceling effects, which again will make more sense if we discuss the theory. So don't worry about nitrogen versus bromine. Do one parameter at a time. Only horizontal and vertical. One parameter at a time. So I'm only going to ask you stuff in the same row or the same column. Okay? Sometimes if they're really mean, like, yeah, they might, but no, usually they do one parameter at a time. Does that answer your question?
Yes, thank you.
Okay. So then what I also really wanted to tell everyone is, yeah, naming. Okay, this and that, and I just want to show you like if there's like a thing here that there's no if, ands, or buts around this one, you have to just memorize. Let's see if we have. Let's see if we have. Okay, there's some rules here. We can go over these. Yes, we certainly will. But again, kind of skipping around here because this table is the most important table in the entire chapter. So I encourage you to have fun with it. If Same thing. I'm just gonna keep repeating it, guys, because it's the same thing. The reason I sucked at C was because I sucked at A and B. So I was struggling in Gen Chem C because I was like, shoot, what's carbonate? Oh man, I can't do the problem because I forgot carbonate kind of thing, right? So some of these I have tricks, some of them are pretty good, and some of them are lame. And I'm gonna just tell you all of them. Carbonate, carbon, she ate. Is it the best trick in the world? I don't care. Carbon 8. 2 minus. CO3 2 minus. Bicarbonate. It's CO3 minus, but there's a little H right there, so that makes it bicarbonate. I don't care. Acetate, CH3COO minus. I can't think of anything. Cyanide, C cyanide, nide, N, CN minus. You have to memorize these, folks. Put flashcards, make flashcards. Thio, every time I see S, that's thio. Cyan 8. She ate. Thiocyanate. All the 8s are minuses, by the way. All the 8s are minuses. We're going to talk about hypochlorite, chlorite, perchlorate, chlorate in a second. Chromate. Okay, I see chrome, chromium, CH chrome, CrO42 minus. Chrome 8. Chrome, she ate. Dichromate, Cr2. Di means 2, so I see chromate times 2, kind of. But then I have a 7. The 7 throws people off. Permanganate, MnO4 minus, permanganate, I don't know. Permanganese, manganese. Mn is manganese. Azide, God help us all. How did they come up with that? God knows. Now, these are my favorite here. So we're gonna talk about these ones. This is what we're gonna start off with. I'm gonna show you my tricks for like the top 5. Hydroxide, we're gonna talk about hydroxide top 5. Peroxide is the biggest exception. This is like a classic Gen Chem, like guaranteed on your exam. Peroxide is almost guaranteed. Phosphate is one of the top ones. Let's start with phosphate, guys, because as soon as I explain phosphate, I think it's gonna make everything click. Nothing for here, nothing for here, nothing for here. I mean, sulfate, you kind of just have to memorize. So I'm gonna give you my tricks for, let's start with phosphate. Let's start with nitrate, nitrite, phosphate. So again, I know this isn't technically what you guys asked because you said, "Hey, we're not there yet. We're doing like naming." Yes, I'm not saying we're done with the naming, but we're jumping to because polyatomic ions. Is that cool with everyone? Technically, you guys are asking about the previous section, but we're in the next section. I think he's gonna talk about it on Tuesday. Is that fine? I'm assuming yes, hopefully. Because again, this stuff
Yes,
is like
sorry.
critical. Okay? So, um, like the one that I'm gonna start off with is nitrate and SNO3 minus. And like my brain, when I see nitrate, I see an N. So I see an N. So I'm like, okay, easy enough. And then I see a minus charge. And then when I see minus, that's ATE. So that's like my hint when I see nitrate NO3 minus. Now the 3, we also have nitrite, which is NO2 minus. So the rule is if I see 3 versus a 2, 3 is bigger than 2. So this one is going to correspond to 8. So that's why I have nitrate. And then again, I see nitrite. So I see N for nitrogen. I see the minus. Okay, that's 8 versus ite. But because I have 2 oxygens, which is 1 less than 3, I'm going to call this ite. So 3 is bigger than 2, so 8. So I like to say she ate more. And ite sounds kind of like cute a little bit. So I say the lame one is nitrate, she ate, nitrite, she ate. I don't know. That's my lame one for that one. So similarly for sulfate versus sulfite, SO4 2 minus. I see S here, so that's gonna be sulfate. And then sulfite SO3 2 minus. So this time I have a 4 here, and you said, hey, wait a second, I thought you said the 3 was 8. No, 4 is bigger than 3. So I see the S for the sulfur part, and then I see the minus charge. Oh, excuse me. Yeah, 4 is big. Yeah. So then sulfate, because 4 is bigger than 3, so she ate more. So sulfate. So she ate sulfate. And then the 3 is less than 4, so she's ite. So sulfate, sulfite. Is it the best trick in the world? No. Is it good enough? Hopefully. So that's for your oxy. These are called oxyanions. When we get to acids and bases, I have some better tricks. There's a really fun mnemonic for acids and bases, but right now, this is the best we got. Any questions about that oxyanions? And then right next to nitrate and nitrite, so you can think of them as like twinsies. And then we have cousins, which is going to be NH4 ammonium. The only thing we have here is the N, and like N. And then I see a plus, so the plus in my brain corresponds to the M, because then I have NH3 is ammonia. Ammonia. So no charge, ammonia. +1, ammonium. This is going to be ingrained in your head by the end of the quarter. All right. So these are all cousins because they're all nitrogen. Let me see if we have any other nitrogen ones. We have azide, which is not really a cousin, but it has an N in it, N3 minus. In my head, okay, in my head, oxygen is blue and nitrogen is green and carbon is red. I don't know why. In my head, oxygen is blue, literally, and nitrogen is green. And that's all the nitrogen ones. We have another oxyanion, which is going to be hydroxide. And this one's kind of easy, especially if you write it like that. I'll let you, in your head, just say it like that. Okay, once we get to Gen Chem C and OChem C, I'm gonna write it like that, make it more fun. Okay, but it's OH minus is hydroxide, which, by the way, also kind of jumping the gun here, but real quick, this comes from water because H2O breaks off a proton to create hydroxide. So if you see hydroxide, just know that it comes from water. Don't need to worry about water right now, but you will soon. So that's going to be a part of our oxyanions. Thank you, Lindsay.
Bye, thank you.
Let's keep going. And we have phosphate. Now let's do the phosphates. So now I have phosphate is PO4 3 minus. So all I have here is the phosphate and the A trick. Okay. And then I'm gonna put on a proton here. So I have hydrogen phosphate. So that's gonna be HPO4. So if I add a positive charge to a minus charge, I'm gonna increase the charge. So I'm going from -3 now to -2. So that's my hydrogen phosphate. And that's that. And then finally, dihydrogen phosphate is now going to be H2. So di means 2. So now I have dihydrogen phosphate, kind of like that. Hopefully this is making sense. Let me pause here, see if there's any questions. Feeling kind of better?
Yes.
Okay. So yeah, for the remainder of the time, let me know, like, do we want to go back to like the elements? Like, again, this is the main thing, okay? So I want everyone to understand this table, do the examples, same thing. Okay. So like any particular, I think this is where you guys are like on currently, maybe kind of. Any particular questions about like what from this chapter? Not really. Yeah, this is gonna be just like naming and practicing and memorize. Use flashcards, okay? Make flashcards, make different practice sheets for the flashcards and the names and the charges too. Should we go over some of the metals now? For example, I skipped these copper ones, copper oxide, binary ions. Should we do these?
Yeah, we could do those.
Okay. Let's do binary ionic compounds. So we need to understand if something is ionic versus covalent. So what makes something ionic versus covalent? Does anyone know? Did he talk about that? So one rule of thumb is if I have something on the left-hand side of the periodic table, which is going to be a metal, and then I'm bonding to the right-hand side of the periodic table, that's going to be ionic. If I have only the nonmetals bonding to each other, it's typically, not always, but typically going to be covalent. And then if I have metals bonding with metals, that's going to be called metallic. Those are metallic bonds. So for this next section, we're going to be focusing on ionic bonds. And then we have, what do we have here? We can do like a few more problems and then call it for today. If I have, for example, let me just do an example here, like NO2. Okay. So I'm gonna start with just this one, which is what? This is just nitrogen. Okay. So this is just nitrogen, and then on the O2 part, that's gonna be, so now I have oxygen here. So I'm gonna write oxygen, nitrogen, oxygen. But the rule is I'm going to eliminate the last suffix here, and then I'm gonna put "ide." So I have nitrogen ide, and then I have a 2 here, so I'm gonna call this dioxide. So the first one's gonna be nitrogen dioxide. Okay? And so similarly, if I have N2O4, I see I have my nitrogen here, my oxygen. The 2 corresponds to di. This time, this 4 is going to correspond to tetra. So 4 equals tetra. So does anyone know the name of this compound? Nitrogen. This one was di. We're going to say tetroxide IDE. Okay? Tetroxide IDE. Okay? Making sense? How are we feeling? A little bit like, okay. Feeling better? Is everyone feeling at least a little bit better than they were?
Yes. I had a question. So,
Please.
do you only like change, because this would be then I'm guessing dinitrogen tetraoxide.
Oh, the dinitro. I forgot the di. Thank you.
But so do you only change like the second part of it? Like you didn't make it like dinitrite or something like that. Like you made it dinitrogen and then
Right.
you changed only like for the oxygen. So do you just change like the second element?
Right.
Y-
So no, I meant to change the first one too, dinitrogen, but you're asking about the suffix. I do not change this, right. I do not change the suffix on the first element. I only change the suffix on the second element, but I do include the di tetra part on both elements. Okay?
Okay. You.
So yeah, some really common questions that's guaranteed on your quiz or test is what's the difference between NO2 versus NO2 minus? So we just discussed NO2 here is nitrogen dioxide, but remember, a few minutes ago, I told you that this was nitrite, okay? So this is just like a memorizing thing. If I see the minus sign, that's my hint that it's going to be ATE or ITE. If I don't see any charges, it's only IDE. And it's going to take practice, just like learning a language. Right now, you're learning the language of chemistry. Okay? And yeah, did he assign homework for this chapter too?
Is that chapter 4?
Yeah, we're in chapter 4, I believe. Yeah,
I believe so. I can check.
maybe. Sure.
He assigned homework for chapter 4 and for chapter 5.
And 5 as well?
Yeah.
Ooh, okay. So what I'm thinking, here's my suggestion for the last several minutes. Um, hopefully the chapter 3 stuff was like really in depth. And then the chapter 4 stuff was like a crash course. Or let's say chapter 3 is a crash course, chapter 4 is just like overview. And then do you mind sending me, do you have like a screenshot of the chapter 5 ones?
It's on the Discord in lecture notes.
On the Discord?
Yeah, in lecture notes, it's the first picture, like the most recent in the most recent
Okay,
bunch. It's the first one.
let's check. That's chapter 5. Oh yeah, yeah, he's definitely talking about Oh yeah, he already started talking about ions. Okay. No, we're not as ahead as I thought. He already started talking about ions. Okay. So please memorize all the ions I was talking about earlier. And what's the homework for chapter 4? So let's check out. He said the first one was, should we try out 447? Let's see what that's gonna look like. So what I was preparing, because I didn't see, because people were asking about chapter 2 stuff. So I was like, oh, okay, they're on chapter 2. But no, that's for review. You guys are on this one here. So based on what we just learned, let's apply that logic to name the cobalt oxides. COO, CO2O3, COO2. All right. Well, what's the first thing? When you see something like this, what comes to mind? They all have what in common? They all have cobalt here, right? And then they all have some oxygen. So all of them are going to have cobalt, right? And the last thing that we didn't talk about is the charges for metals. So this is going to be a metal. And here's how we do this. So remember when I told you earlier that my oxygen, does anyone remember what charge my oxygen has?
-2.
Very good. So my oxygen over here has an invisible -2 charge. If I see I have an invisible, and then so I also am going to put oxide here. So I have cobalt oxide, something, cobalt, something, oxide, and then something, cobalt, something, oxide. If I have -2 here, then my overall charge, I don't see an overall charge. There's no charge. So if my oxygen is -2, what does my cobalt have to be to balance out that charge?
+2.
Very good. So if this is -2, this is going to be +2. So then I'm going to put cobalt +2. But the rule is I had to do a Roman numeral +2. So this one, CO, is cobalt 2 oxide. And now let's repeat that process for any questions about that one? Notice that there's no mono or anything like that anymore because it's a metal. It's just cobalt 2 oxide. I don't got to worry about the tetra stuff either. So now I have cobalt. One trap answer is cobalt monoxide. That's not a thing. Cobalt monoxide. That's a trap. Okay, because it's a metal. That's the key difference here. A trap here is dicobalt trioxide or something like that. That's a trap. It's not dicobalt trioxide because it's a metal. So for my metals, I need to have a Roman numeral. And I don't worry about the suffix. So another trap here is going to be mono cobalt dioxide. Trap. It's a metal, so I have Roman numerals. So I look at my charges. Once again, my oxygen is what charge? So earlier you said it was -2. But how many oxygens do I have?
3.
Times 3 equals -6. So how many? So what does now the tricky part is what does my cobalt have to do here to be balanced out to make a -6?
It would have to have a charge of -3, so then of +3, so then you'd get 3 times 2 and then 6 and it would balance.
Good job. And the trick for that is, let's try that. So then we have cobalt 3 oxide. Good job. And then the trick for that is we have cobalt 2 oxygen 3. So I call this the crisscross method. We're going to do a crisscross. So then our cobalt has a 3 plus on top, and our oxide has a 2 minus on the bottom. So that's how we get our cobalt 3. Let's do that trick crisscross for COO2 one more time. So there's an invisible 1 right here. So I can do that whole balancing out thing. I'm going to do it quickly. -2 times 2 equals +4 -4. So I should expect to have a 4 here. Okay, but what I'm going to do is the crisscross method, because I see that I have cobalt +2. And my trick didn't work here. Why didn't my trick work? Cobalt O -1, cobalt 2. I'm not sure why the trick didn't work here. So the trick didn't work here because there was, how do I explain? It's kind of like a least common denominator thing from algebra class that they attained COO2. There's an invisible, I don't want you to worry about it, but it came from the facts that we have CO2O4. If I did it this way, then we would get CO4 plus. So the correct answer is CO4. I want you to do it this way because my trick broke down in this case, unless you realize it came from an LCD. I don't want you to worry about the LCD thing here. Do this way, and we're going to see we get -4 plus 4. We get cobalt 4 oxide. Okay.
Do you write the Roman numeral just for is that just transition metals or just like metals in general? Just transition metals.
Just transition metals. Yes, that's what I meant to say
Okay.
earlier, because lithium or whatever one we saw before was also a metal, but it was not transition metal. Okay, the one we did a second ago was yeah, we did one a second ago where that didn't apply, but it was still a metal. This is only for transition metals, but it's always the case for transition metals, so you don't have to worry about it. Okay. And then, great. When's the exam?
I think the 19th of February.
19th?
Yeah.
So basically, he's going to finish up chapter 5. He's going to start chapter 6. No, chapter 4. He's going to start chapter 5. All right. So since it's coming to the end, my next thing is, do we want to just briefly take a look at chapter 5, and then I'll just give you some general tips so you can have an idea of what to expect?
Yeah, we can do that.
Sounds good?
Yeah.
So let's just kind of like go through. And chapter 5 is called Bonding Theory, Molecular Geometry. So this chapter has no math. This chapter has no math. The most important thing for this chapter, so I want you to go through, understand bond angles, VSEPR, go through the theory. I want you to understand steric numbers is really important. But if you can understand this stuff right over here, let me show you the most important thing you can do. This is all going to be Lewis structures. Chapter 4 directly builds into this chapter. Go through the lone pairs and the central atom, and I have videos on these too. I'm gonna send these to you guys. If you can understand this table, this will help the most for this chapter. So this table is the most important thing. And let's take a look at what we have here. H2O is water. What does that look like? It looks like an oxygen molecule bonded to H and H. And it has this shape. The name of this shape has two names. One is bent because it looks bent, but it also is called, so that's the first name is called bent or angular, but the other name is called tetrahedral. So tetrahedral means that it has a particular angle of 109.5 sp3 hybridized, super important for OChem. All of general chemistry, super important. Then, if you say, hey, I don't understand tetrahedral, what does that mean? Let's look at a molecule. All of these are shapes. They look like different shapes. Let's just look at the shapes. Just want you to see. Wait, I want to see another table with the shapes here. Hold on a sec. This table is important, yes, but there's typically another table where they explain it with the shapes. Oh no, I'd be surprised if they don't have the shapes. Okay, this is where it gets very theoretical. And heads up, I studied this chapter super hard, and like the theory typically is not very like tested. So don't worry too much about the theory in this chapter. Like, yes, I want you to understand hybridized orbitals. This is the hardest thing in Gen Chem A. If you can understand this diagram, you're ready for OChem. If you can understand this diagram, you're ready for organic chemistry, but you don't need to worry too much about the theory for hybridization. It's more about the shapes are the common questions. It's more about the shapes that that table was what I was trying to show you. This is also organic chemistry. Literally, this is now, I like to call this pre-organic chem. Pre-organic chemistry. It's not, Eduardo, but I'm gonna drop it later if you want. I just want to find one more table that's gonna show the shapes here. I don't see it. I'm just gonna look it up on Google. See, don't get scared. Like, he might ask this, but in chapter 3, he's definitely gonna ask these ones for Hund's rule. But for chapter 5, he's probably not going to ask the MO diagrams to this extent, because now we're getting to like quantum chem, and it's typically not tested. It's gonna be more like, yeah, it's a lot of theory. It's a lot of theory that I never see people ask this. Okay, I'm gonna look up the table that I'm talking about, then we'll end it for today. VCPR table. It's kind of like the one I showed you, but I want the shapes here, because if you can see the shapes, you're gonna see all the shapes. It's gonna click. Kind of like this, but I want the shapes. OChem Tutor has the videos too. You can check out OChem Tutor. Kind of like this. I don't know, I'm having trouble finding it. Yes, this is what I wanted. Okay. So if we have bonds to double bonds and it's in a straight line, that's called linear. And then if you have a bond connected to 2 to 3 things, well, guess what? It looks like a triangle. So now this complicated ammonia looking thing is nothing but a triangle. And you're saying, hey, I don't get tetrahedral. He keeps saying tetrahedral, tetrahedral. It looks like a tetrahedron. And then you're saying, hey, I don't get trigonal bipyramidal. He keeps talking about trigonal bipyramidal. I don't get it. Look, it's a pyramid on top of a pyramid, so it's called a bipyramid. And then I don't get octahedral. He's talking about octahedral, so it looks like another pyramid on top of another pyramid, just like that. So if you can see the shapes, then it's gonna clear up everything. You can see what each one looks like. And practice those out. Okay? So cool. Any other questions? Cool, cool, cool. So how are we feeling? I'm thinking we kind of end a little bit early. I think we went through a lot. We basically did a rundown, chapter 3, chapter 4, and then just like a brief overview of chapter 5. Tips I always give is just do practice problems. Always say practice problems. Go
Are you
ahead.
gonna do more of these sessions?
Yes. Yes, I am.
Good.
Was it helpful, Eduardo?
Yeah, definitely.
Cool, man. I'm glad. Yeah, you already took Gen Chem, right? You already finished it?
Yeah, but it's been years, so
Oh, dude,
yeah,
yeah, yeah,
yeah.
yeah, yeah. There will definitely be more. I'll keep everyone posted. All right. Sounds good. Pretty much let's end it here. And then again, I'm gonna send everyone the recap if you want to rewatch it. It's gonna start to click if you rewatch from scratch. Um, and yeah, cool, cool, cool. And if it's all right with everyone again, I'm gonna post it on YouTube as well, so that way I can share with folks that couldn't attend. And just let me know if anyone has any inquiries about that. But cool. That being said, good job, everyone. Really appreciate you guys interacting, commenting. Cool. And yeah, so keep an eye out on the Discord if you want to attend further sessions. And you already know that I got you if you need tutoring for Gen Chem Math, OChem Physics. And yeah, I'll keep you guys posted for the midterm review. I'll probably do one right before the next midterm. Sounds good?
Yes, thank you so much.
Thank you.
Why, thank you.
All right, bye-bye. Bye-bye.
Thank
Have a
you.
good day, everybody.